right, today we're going to be talking about rational expressions and more specifically how to simplify them. And it's going to require a lot of factoring, kind of like we've worked on in the past. To start out with, what are rational expressions? A rational expression is an expression that can be written as a ratio of two polynomials, meaning you're going to end up having a fraction that's going to have two polynomials in it. It's basically a fraction that's going to have a variable of some sort in the bottom, in the denominator. An excluded value is a number that makes a rational expression undefined. Now, I know a lot of times when you think about the term undefined, you think about slope. Well, whenever we have a rational expression that is undefined, that means that the denominator is equal to 0. And you know, fractions, they're basically division problems. So we can't divide by 0. That's a rule. So anything that would make the denominator, the bottom number of a fraction, equal to 0, that would be an excluded value. And we're going to talk about how to find these excluded values here in just a second. A rational expression is in simplest form when the numerator and the denominator have no factors in common other than 1. Meaning there's nothing that you could factor out, nothing that you could cancel, no greatest common factors, nothing that can be reduced. It is as broke down as far as you can get it. And we'll be practicing that here in just a minute as well. All right, so starting out with excluded values. Remember, we just said excluded values are anything that would make the denominator equal to 0. So what we do is we start out by looking at the fraction, and we just set the denominator equal to 0 and solve. So for the first one, you're going to take the denominator. So this time that would be 6x, and you're going to set 6x equal to 0, because we know we can't divide by 0. So anything that would make that denominator 0 is going to be an excluded value. Well, once we set that 6x equal to 0, we can just solve for x. We want to get x by itself over here. So the opposite of 6 times x would be to divide by 6. And whatever we do to the left, we got to do to the right. So 0 divided by 6 is going to get us 0. So the excluded value for the first one is 0. X can be any number in the whole wide world, but it can't be 0. All right, number two, we just look at the denominator. We're going to set that equal to 0. So 3x plus 12 equals 0. Now we just got us a two-step problem. We got to solve for x, get x by itself. So subtract 12. Whatever we do to one side, we got to do to the other. So 0 minus 12 is negative 12. Now we got 3x equals negative 12. The opposite of 3 times x would be to divide by 3. So if we divide both sides by 3, negative 12 divided by positive 3 is going to give me negative 4. So that means the excluded value for number 2 is negative 4. All right, skipping on down to number 3. Number 3, I have x squared minus 4 in the bottom. And I'm going to set that equal to 0. That's supposed to be a minus sign, I apologize. X squared minus 4 equals 0. All right, trying to get x by itself. So let me add 4 to both sides. Add 4 to both sides. So 0 plus 4 is 4. I end up getting x squared is equal to positive 4. Now, just like the opposite of multiplying is dividing, the opposite of adding is subtracting, the opposite of squaring a number is to square root the number. So to get x all by itself, to get rid of that squared, we've got to square root both sides. Square root of x squared is x. The square root of positive 4, almost everybody's going to come out and say 2. But remember, with square roots, you actually have 2 roots. it's going to be a positive 2 and a negative 2. So there are two values that would make that one undefined, positive 2 and negative 2. All right, our last one. We got to set this denominator equal to 0. So looking at number 4, I got x squared minus 3x minus 10 equals 0. Well, I got me a trinomial, and the leading coefficient is 1. So this really looks like something that we could probably factor. So if we look at it, I need two factors of negative 10 that would add up to negative 3. So that means I'm going to need 2 times 5, and the 5 is going to need to be negative because it's got to add up to negative 3. So to write that as factors, I got x plus 2 and x minus 5, and I'm still setting them equal to 0. So I got to find my solutions there. So whenever I do that, if I say x plus 2 equals 0, subtract 2 from both sides. So I'm going to get negative 2. X equals negative 2. There's 1. All right, now I got to scoot over and deal with my x minus 5. X minus 5 equals 0. Add 5 to both sides. Add 5 to the right. 0 plus 5 is 5, so x equals 5. There's my other. So I got negative 2 and positive 5. Those are my excluded values. Remember, excluded values are any number that would make the denominator equal to 0 because, as a rule, you cannot divide by 0. When we start graphing, you'll learn that these excluded values are actually what's called asymptotes, which means it's a place that the graph never is going to touch. All right, moving on. Dividing out a monomial, meaning let's see if we can find us a greatest common factor, or a GCF as we used to call it. All right, things they have in common. When we look at number 5, I'm looking for things that might be the same on the top as they are on the bottom, because when that happens, that means I get to cancel stuff out. So, looking at number 5, I'm seeing I got me an x on the top and an x on the bottom. And they're just being multiplied. There's nothing being added or subtracted to it. So as long as they're just being multiplied there, my x and my x on top and my x on bottom, they can cancel out. Well, that's just going to leave me with a 3 on the bottom. But I can't just leave 3 on the bottom and not put anything up top. If everything cancels out at the top of your fraction, that means we just need to put a 1 there as a placeholder. So when you divide out a monomial, when you divide out that x, all we're left with is 1/3. We simplified it. All right, number 6. Number 6, we got to see, is there anything that we could divide out of the top and the bottom? Well, as I look at it, I notice I've got a 2 on the top, and I got a 2 on the bottom. Since I've got a 2 on the top and a 2 on the bottom, and they're just being multiplied, there's nothing being added or subtracted to it, then I can drop those 2's. So that's going to leave me with just x on top, and I got x minus 3 on the bottom. Now looking at these, I simplified out the 2's, all right? But my first question would be, can I mark out the x's as well? But this time the answer is no, because that x is tied to the minus 3 in the bottom. Anytime you have x being added or subtracted to anything else, it's kind of like a family. You take all of it or nothing at all. You have to be able to mark out the whole x minus 3, but you can't mark out just the x or just the minus 3. It's kind of an all or nothing deal whenever there's something added or subtracted to it. All right, let's look at number 7. Number 7, when I look at it, I'm checking out these numbers. I got a 5, I got a 10. If I look right there, I know that I can divide out a 5 out of the top of that fraction. There's also something else that both of those terms have in common. They both got x's with them. This one's got x squared. This one's got x to the 3rd. So when I'm factoring out a GCF or a greatest common factor, I can pull out the biggest number I could divide both of them by, and I can pull out a variable, but whenever I'm doing so, I can only bring out the smallest amount of that variable. So what I mean is, I could only divide out x squared because x squared is the lowest amount. So if I were to take 5x squared from each one of the terms on top, let's factor it out. Anytime we factor, we're going to have leftovers. So I have 5x to the third. If I divided out the 5 and I divided out 2 of those x's, 3 minus 2 is going to leave me with just 1. So my leftover here is going to be x to the 1. Okay, I'm moving to the second term. I divided out a 5, so 10 divided by 5 is going to be 2. And then I divided out x squared. Well, that's all the x's for the second term, so all those x's go away. So my leftover here is just going to be plus 2. Now I got to see, can I reduce anything with what's on the bottom, that 20x squared? Well, 5 over 20 will definitely reduce. I could divide this by 5 and get 1, and divide this by 5 and get 4. Now look what we got on top. I got x squared on top and I got x squared on the bottom. If you've got the same on top as you do on bottom, they cancel each other out as well. So that leaves me with just, I got 1 times x plus 2 on the top. And we don't really have to write that 1, do we? I got x plus 2 on the top. And on the bottom, I got this 4 because everything else canceled out. All right, looking at the next one. 3x over x plus 7. Okay, there's nothing I can factor out to begin with, not like your greatest common factor. Okay, I know some people are probably like, oh, I got x on top and I got x on bottom. But there's one thing that makes it where we can't touch that x on the bottom. It's part of a family. It's x plus 7. We would have to either cancel out the whole thing or nothing at all. So since I can't touch the x's, and there's nothing I can factor out, this one is already simplified. It checks out. So my simplified version would be 3x over x plus 7. Okay, sometimes we can divide out a binomial, which means like a factor pair or a whole family. All right, so number 9, we're going to have to factor that thing. Remember, this is where we said I need 2 factors of the last number that would add up to the middle number. So I need 2 factors of -3 that would add up to +2. That would be 3 times -1. So to write 3 and -1 as factors, we would just put x plus 3 and x minus 1. On the bottom, we got to do the same thing. I need 2 factors of 15. That would add up to 8. Well, that would be 5 times 3. So to write 5 and 3 as factors, I would write x plus 5 and x plus 3. So I've got them all factored out. Now here's when the good stuff starts happening. When you see that you have the same factor on the top as you do on the bottom. Like for example, this one, I have x plus 3 on the top and I have x plus 3 on the bottom. When you have the same factor pair on top as you do on bottom, good things happen. X plus 3, x plus 3, you can cancel them out. So that's going to leave me with x minus 1 on top and x plus 5 on the bottom. Broke it down as far as we could. All right, looking at number 10. Number 10, we're going to do the same thing. We're going to factor out everything we can. So I need two factors of -8 that add up to 2. Okay, so factors of -8, that would be 4 times -2. So to write 4 and -2 as factors, we would write x plus 4 and x minus 2. Now we got to factor the bottom one. Well, that's a perfect square factor. X squared minus 4. That's the same thing as if we had x squared plus 0x minus 4. Two factors of -4 that would add up to 0. Well, that would be -2 and +2. So to write those as factors, x plus 2, x minus 2. Now let's check and see if we can mark anything out. I got me an x minus 2 on top and an x minus 2 on the bottom. So since those cancel out, that means I can have x plus 4 on the top and x plus 2 on the bottom. There it is. All right, going on to the last one. Recognizing opposites. Sometimes my factors might end up being flip-flopped around to where I can't necessarily cancel them out, but there is a rule that we have to be able to recognize. So we still go about it the same exact way, looking for greatest common factors, looking for factors, anything that we can cancel. All right, so this first one, I got 3x minus 9, and so my GCF, or greatest common factor here, would be 3. So let me divide out a 3 and see what's left. So 3x divided by 3 would make that just 1x. And -9 divided by 3 would make this -3. So I got my greatest common factor out on the top. Now I got to look at the bottom. Now what I'm going to do, I'm going to flip-flop it so it kind of looks like what you're used to seeing. I'm going to rewrite this. I'm going to switch these spots. I'm going to put -4x squared in the front plus 12x. And now let's take us a greatest common factor. Well, I know both 4 and 12 can both be divided by 4. So let me pull out a 4. I know they both actually got x's with them, but remember, I can only take the lowest exponent of x that we've got. So this time that means I can only take the x to the first. So that's going to make that one come out. So if I divided by 4x here, -4x squared divided by 4x, that's going to be -1. And then x squared divided by x, that's going to leave an x left over. Now I got to divide the second one by 4x. 12 divided by 4 is going to give me a +3. And then x divided by x, they're going to cancel. So my second term doesn't get an x. But now here's what we got. Look at my opposites here. This one is x minus 3. This one is -x plus 3. Okay? These are actually opposites. When my signs of both terms are opposite, like +x turned into -x, -3 turned into +3, when they are opposites, that automatically actually equals -1. Opposites are equal to -1. Okay? So what we can do is this whole thing is really going to equal a -1, which is going to make the whole fraction -3 over 4x. I know that's a little bit confusing, and we're going to keep practicing so that we can find those opposites. All right, let's look at number 12 and check for opposites. Okay, let's factor out the top. On the top, I need two factors of negative 12 to add up to negative 1. Factors of negative 12 to add up to negative 1. Well, that would be negative 4 and positive 3. So x minus 4, x plus 3. All right, now I got to factor the bottom. So let's see, I have negative x squared. And I have 16, okay? So this would actually be negative x squared plus 16. So we got to factor that guy out. So let me factor out a negative 1 to begin with. Let me go ahead and pull a negative 1 out of this. Negative 1 times x squared minus 16. Because when I do this, that turns my second one into something I can factor as a perfect square factor. That would be x plus 4 and x minus 4. Okay, but I got this negative out front. That's going to mess up the whole thing. So look right here. If I say this, if I distribute this negative, that's going to make this a negative x minus 4. And then I've got x minus 4 as well. So now I'm starting to look at my stuff.